We continue by talking on how to detect multicollinearity, and the first test we're going to be discussing here are the informal tests. So let's look at the first way we can use to detect multicollinearity. And we should know that most cases in a problem of multicollinearity, it's not really about the presence or absence of multicollinearity. It's more of the problem of the degree at which multicollinearity exists between our independent variable. So let's look at this one. There exists collinearity if correlation obtained differs significantly when you divide the data sample into two halves and analyze separately. In this case, let's say you have a observation of a particular problem you are of interest to you, and you have like observation that is, let's say, 30. You might divide the observation into two equal halves. That means 15 observation at one part, 15 observation at the other part. You analyze each of the 15 observations separately, and when you analyze, you compare the results of the two separated observations, the 15 at one part, 15 at one part. When you compare the results, when there is a large difference, and then the results obtained in the two different observations, if there is large difference between them, and then you could suggest that there is a degree of multicollinearity present in the regression analysis data. So let's look at another one. It's just simply by checking the correlation matrix analysis between the independent variable. And if you recall, most of the independent variables, actually some of them there is possibility of a level of correlation between this independent variable, but as was said earlier, it is the degree that actually, when the degree is high, that we will be having a problem. So checking out your correlation matrix, you're able to know the degree of correlation that exists between your two independent variables. This is also an informal test you can use. You can know none of these tests we've mentioned so far, none of them is a confirmatory test. They are just a test to suggest to us. So let's look at the third one. The third one talks about you add or delete some x variable, or what we can say some x observation, and the regression coefficient change dramatically in signs. So what are we saying here? We are saying that as let's give you an example of the observation of a data with that 30 observation. When you first have the regression analysis of that 30 observation, you consider the sign of each of the coefficient. Let's assume we're having a data with 3 independent variables. You consider the coefficient, the sign of the coefficient of x1, of x2, of x3. Let's assume at the first analysis of the 30 observation, they are all positive. x1 coefficient is positive, x2 coefficient is positive, x3 coefficient is positive. So after doing that, you probably remove 1 or 2 observation away from the 30 observation. Initial was a 30 observation. You find that your x1, x2, x3 coefficient are positive. So probably you remove 2 observation out of the 30, left with 28 observation. You analyze, you perform a regression analysis on the 20th observation, and you check again the coefficients of your independent variable for x1, x2, x3. If probably 1, 2, or it could be all of them decided to change sign and become negative, or even just one, it's sufficient to suggest a degree of multicollinearity that needs to be verified. So let's look at the informal test, that is conducting a variance inflated factor. This actually will help us to show the degree of multicollinearity present. And if you look at talking about VIF, VIF is more a rigorous way to detect multicollinearity. Not only to detect multicollinearity, it's going to also help us to know where multicollinearity actually exists between the independent variables. So let's look at this. To have our variance inflated factor, popular called VIF, It's just having 1 divided by 1 minus the r squared of the individual independent variable. So let's assume that we are to obtain the r square for independent variable. We are interested in 3 independent variable when x is 1, when x is 2, when x is 3. For us to get the r square for the very first independent variable, which will help us in estimating for their variance inflated factor, to obtain this we need to regress our x1 on x2 and x3. What are we saying here? We are going to treat our x1 because we are interested in getting the r square for the independent variable 1. So we treat our x1 as y. We treat it as y, not that is our y, but we treat it as y in this case, so to say, and we regress it on x2 and x3. So when we do this, we estimate our r square. So for us to get also for the r2, so we regress x2, treating our x2 as y, so we regress it on x1 and x3. So after doing the regressions, we're able to get our r square for r2. The same thing we apply also for r3. Alright, so given a regression model of this nature where we are having just 3 independent variable x1, x2, x3, so what we do? We regress the independent variable of interest against each other. So for the r1, which is we want to find out the variance inflated factor for x1. For us to do that, we need to get this value for the x1. So we're going to have a new model. You can see this is serving as y, treating it as y. So this is a new intercept. We represent it by alpha naught. So this is alpha 2, alpha 3, representing the coefficient for the independent variable, and this is the error term. We'll do the same thing. Since we are interested in finding VIF for x2 also, we need to get the r square for the x2. So if we use this as the intercept, the slope, and also the same thing for the third one. So this is the derivation for the variance inflated factor, and we say variance inflated factor is a measure of how much the variance of the estimated regression coefficient is inflated. So we want to see how much of the variance is being inflated. So we are already at the point of saying that a multicollinearity is just a matter of the degree. So we know that probably the variance may not be precise what we are, but what is the degree of the diversion for what actually we are expected to have. So when we are talking about the variance inflated factor, is when we say it's 1 or close to 1, so it means that there is no correlation among independent coefficient. That means we need not to worry about multicollinearity when we have our VIF to be close or equals to 1 or close to 1, as it were. So some text suggested VIF that exceed 4 need to be probed further or to be investigated. Some text also suggests when VIF is greater than 5, that's when we need actually to look inward and see what we can do. But you might decide to choose any one of interest, but I will still want us to still stay with 5. So when we have VIF greater than 5, there is need for us to investigate and see what is happening. But when we have the variance inflated factor more than 10, it shows it's a sign of a serious multicollinearity problem. So let's look at some of the solutions to multicollinearity. To start with, I would like to say there are two schools